Once we are comfortable with the adhesive to use, it's time to apply it. It's time to discuss manufacture. How you apply the adhesive, the pressure you apply, the temperature of the cure, the time of curing. All these things are very important and will be seen in Module 6, Manufacture.
At this stage, we know about surface treatments, we know about adhesives. We are in a position where we can manufacture, which is what we are going to see now. We are going to see all the steps involved in the manufacture, especially with film adhesives, the most important adhesives in the aeronautical industry. So these are the steps involved in any manufacture. Adhesive storage, the shelf life, that's an important factor, in general about 6 months. Surface preparation, this is so important. It has such a big impact in the final strength that we dedicated actually one module to this. Then adhesive metering, adhesive mixing. In case of films, that really doesn't make sense because this is already done. Adhesive application, assembly, very important because the adhesive takes time to harden, so we need tools to fix it in position. Then the control and the hardening. About the storage, as I told you, we are talking about 6 life for the shelf life. But what defines, in fact, the storage is the viscosity of the adhesive. And the viscosity is more or less constant for 6 months. From that point, it starts to increase, and then you cannot get a good mixing and you cannot get a good application of the adhesive. Films, or one-part epoxies, which are normally used in aerospace applications, they are stored at low temperature. It can be in the fridge or even in the freezer at -18. So it's very important to take some precautions when you use this adhesive. First of all, you should take it out of the freezer, and you cannot apply it right away. You should leave it so that it comes to room temperature and you don't have any condensation of water, which will damage the adhesive. After it's at room temperature, then you can cut with scissors the adhesive, the part of the film adhesives that you want, and then you apply it. So very, very important for the products that are stored at low temperature to take the time so that they come to room temperature to avoid condensation of water at the surface of the adhesive. If you use a paste adhesive, there are some precautions, some care that you should follow to avoid air entrapment. For example, this pattern or this pattern are not recommended because you tend to trap air here and here. It's better to apply one line or a zigzag so that the air can escape through the sides. So that's the recommendations for paste adhesives. For film adhesives, this is very, very easy to apply. It's a fantastic product. There is no waste, very easy. You don't need mixing, metering. These kind of things are completely avoidable. I can show you now an example of how we do it. You will see that this is really a treat. So imagine I want to bond these two composite materials with a film adhesive. So I'm going with my film adhesive to determine the quantity that I want. Okay, I can put a bit more if needed. So I'm going to cut more or less just for you to have an idea of the steps involved and how easy it is. Okay, I'm going to use this and then a square part. Okay, that's it. Very easy. Then you have protective coatings on each side. You remove one part. That's it. Usually you should do it with gloves. It's not very nice to contact the adhesive with your skin, but if you do it once in your life, no problem at all. Then you apply it on the surface. With your finger, you guarantee that you are not trapping any air. It's a good thing to do, you see. Air entrapment with film adhesive is a nightmare. I will explain you in the next slide. Then you can remove the other coating. That's it. and then you apply the other substrate. Of course, I'm not doing the surface treatment parts because we already know that. That's it. We need to apply pressure. This is very important for film adhesives. You can use some springs, one, another one, to make sure it's well bonded. And this would go to the oven to allow the cure of the adhesive. You see? I don't have any adhesives in my fingers, no waste. I can control perfectly the amount I need. I was talking about air entrapment, so this is well explained here. Even though with my fingers I try to remove the air entrap, you still have, okay? And then during the cure, when the adhesive goes liquid, this trapped air tends to go inside the film, and this will cause porosity. How do you avoid this? You avoid this by really applying a lot of pressure in the joint. That's why film adhesives, even if they are epoxy adhesives and that don't cure by condensation, they always need a lot of pressure, precisely to avoid porosity due to air entrapment. Okay? So, very important to have a good fixturing device for voids and porosity, but of course to keep the surfaces in contact, to avoid adhesive thickness variations, and of course to allow a good wetting. Which fixturing devices exist? But in the environment of the lab, we have molds like this one, used for single up joints that will control the alignment, the adhesive thickness, the excess of adhesive at the ends of the overlap, the length of the overlap, etc., etc. In the case of films, you saw that I don't have anything special to control the adhesive thickness and apply pressure. Still, there is something in the adhesive that is going to control the adhesive thickness. It's a carrier. It's a kind of mat of tissue that is in the adhesive, and that will control the adhesive thickness. Finally, we will have a thickness that is similar to that of the carrier. That's how it's done, the control of the adhesive thickness in the case of films. Okay? This kind of fixturing device, of course, is very manual. In the case of industrial applications, you want something more precise, more controllable. One of the devices used a lot in the aerospace aeronautical industry is the autoclave. Basically, it's an oven with hydrostatic pressure inside that can allow precisely good pressure to avoid porosity and to make sure that the joint is properly made. Then comes the hardening. The adhesive we use in aerospace industry, they need temperature in general. So, for example, 1 part epoxy, typically it cures at 120 degrees for 1 hour. That's typical time and temperature. If you go for something more performant, like a bismuth, then this is done in 2 stages. First, a cure at 175 for 2 hours. You remove the joint and you further cure it at 230 for 2 hours to avoid too much residual stress in the adhesive. If you want to accelerate the cure, you can use more temperature, but be careful. You shouldn't over-cure and use at too high temperature, because this can even damage the adhesive. Many times you want to apply a local heating. For example, you have a damage in the wing and you want to repair. Of course, you are not going to put the whole aircraft in an oven. What you do is that you repair the damaged area, you put a laminate on top and then a blanket, and you heat it with that heated blanket, and like this you can heat locally your joint. This is a typical case in the aeronautical industry. And that covers the manufacture. You know the tricks, you know the things we have to be careful with. And in general, we are talking about film adhesives that need special care about air entrapment. We need quite a lot of pressure.